greenhouse gas is the main cause of global warming nowadays. Buildings consume approximately 40% of the energy worldwide and left a huge amount of carbon footprint to our Earth. Hence, building is one of the most important sectors that we can investigate to mitigate the climate change. Energy audit is very useful in improving the energy efficiency in buildings and reducing the carbon footprint. What is energy audit? An energy audit is a systematic investigation of energy use and energy consumption to identify the opportunity for energy efficiency. Now, why do we need an energy audit? Energy audit enables us to check whether the energy is being used efficiently or not, and to identify the opportunities for energy saving and develop a database for tracking the energy use. There is three levels for energy audits, namely the preliminary energy use analysis and walkthrough analysis for level 1. Level 2 is energy survey analysis, while level 3 is detailed analysis of capital intensive modifications. In level 1, there is preliminary energy use analysis or PEA. The activities in level 1 is to determine the building's net floor area, collect the electricity bills for at least 1 year, and preferable 3 years, and also calculate the building energy index. The building energy index can be calculated by dividing the total energy consumption per year to the occupied or net floor area. After you have obtained the BEI, you can compare the BEI with those of buildings having the similar characteristic. And the recommended BEI for commercial buildings is 135 kilowatt-hour per meter square. And then you can review the monthly bills and also monthly energy consumption pattern for detecting the irregularities. So these are the examples of findings for the preliminary energy audits, such as the building energy index and also the building history compared to the baseline model. So in the walkthrough analysis, you will perform a brief walkthrough survey of the facility to get familiar with the constructions, equipment, operation, and maintenance, and to uncover the major or glaring problems area. After that, you can have a brief interview with site operating personnel to learn of operations and maintenance issues, and to identify the low-cost and no-cost energy saving measures, such as LED, thermostat control, etc. And these are the examples of low-hanging fruits. For example, you can have the temperature settings of your air conditioning system to not lower than 24 degrees Celsius. And you can change the existing fluorescent tubes or incandescent light bulbs to the LED. And choose the high energy star appliances, okay, which is energy savings appliances. In level 2, energy survey and engineering analysis, you can review the mechanical and electrical system design, install conditions, maintenance practice, and also the operating methods. Then you can measure the light intensity, indoor and outdoor temperature, energy consumption or significant energy use, SEU, and also the HVAC parameters such as energy consumed, airflow, cooling, and return water temperatures, and to identify the key operating parameters of each SEU. You can analyze the daylighting, solar heat gains, and shedding, energy portfolio, energy consumption patterns, and performance of the SEU. And finally, you can list all possible modifications to equipment and operations that will save energy. For example, variable speed drive or variable frequency drive for motor control. Estimate the implementation cost of each practical measures, including the maintenance cost, and estimate the potential saving, including the electricity bills, maintenance costs, downtime costs, etc. And prepare a simple financial evaluations for the saving measure. These are the example findings for level 2. For example, you can construct an energy portfolio as shown here. Then you have an idea of how much energy is consumed per each appliances or activities. In level 3, a detailed analysis of capital intensive modifications will be conducted. So you will expand the definitions of all modifications requiring further analysis, review the measurements methods, and perform the additional tests and monitoring to allow the determinations of feasibility. Prepare a schematic layout of each modification and estimate the cost and saving of each modifications and each integrated bundles of modifications, and perform a life cycle cost analysis to meet with the owner or operator to discuss and develop the recommendations. This is the findings of the for level 3. Okay, you can actually put down in terms of categories for efficiencies, year service started, year service end, electricity use, demand, electricity cost, demand charge, and also the capital cost. With this details capital intensive modifications analysis, you will be able to identify the saving of this measure more accurately. And thank you very much for listening. And this is my sharing about the energy audit.